Okay, so next question here I've been asked to do is 2014 6-part D, okay? So we're asked here to write the balanced equation for the complete combustion of butane. Butane firstly has a formula C4H10 plus. Combustion is always when it's burned in oxygen and it always produces carbon dioxide and water. Now, this particular question is quite difficult. C4. So that means I must have 4 carbons as well on my right hand side. If I look here, I have H10. So that means I must have 10 hydrogens on the right hand side. I already have 2, so what by 2 gives me 10? 5. Next, then I have to look at my oxygens. So 4 by 2 here gives me 8 oxygens plus 5 oxygens. And that gives me 13 in total. So, what by 2 gives me 13, 6.5. So that is my complete combustion there of butane. And I'm asked, calculate the heat of combustion of butane, given the heats of formation of carbon dioxide, of water, and of butane itself, C4H10, are minus 393.5, minus 285.8, and minus 125.7. So, to make carbon dioxide, it's C plus O2. To make water, it's H2 plus a half O2. And then to make C4H10, it's 4 C's plus 5 H2s. What I do now is I compare that to what I see up here. So, I'll just start with, doesn't really matter which one we start with. So this is my carbon dioxide here. I have them both on the right hand side, but I have to multiply this by 4 because I've 4 up here. H2O again, both on the right hand side, but I have to multiply this by 5. And if I look here, my C4H10 is on my right, but up here it's on my left. So I have to reverse that. So I'm just going to do that. So I have 4C now. Plus 4O2 goes to 4CO2. I have 5H2 plus 5 over 2O2 goes to 5H2O. And finally then I'm reversing this one. So that means it goes to C4H10 to 4C plus 5H2. And now I'm just going to do what I did there by working out these. So minus 393.5 by 4 gives me minus 1574. Minus 285.8 by 5 gives minus 1429. And finally, I've reversed this one, so it becomes 125.7 as a plus. Now what I'm going to do is I compare again, left-hand side, right-hand side. Anything that we see cancels. So 4C, 4C, 5H2s, 5H2s, and that's it. So I have C4H10 plus 5 over 2 is 2.5 O2 if I was to convert it. So that means it is 6.5 O2. And that goes to 4CO2 plus 5H2O. And if I look at what I have up here, it is the exact same. So I have 125.7 minus 1429 minus 1574. And that gives me an answer there of minus 2877.3 kilojoules per mole. And that is your answer. Okay, hardest part here is working out this equation. Remember, always burns in oxygen to produce carbon dioxide and water. Compare your number of carbons and hydrogens with what you see on the right hand side, and then work out your number of oxygens.